Welcome to the deep dive. Today, we're getting right into a really big technical hurdle, moving high-resolution video over long distances.
Yeah, it's a huge problem.
And we're looking at a new class of connector that seems to solve it, specifically the DVI-Gear Hyperlight Active Optical Cable.
Right.
So our mission today is to figure out how these things get around the signal problems that make long 4K video runs, such a nightmare.
It's a fundamental shift in technology.
Okay, so let's just get right into it. If you try to run a standard copper HDMI cable, say more than 50 feet or so.
You're in trouble.
Right, especially with high bandwidth stuff, the signal just starts to fall apart. It's a huge bottleneck.
Exactly. And when you're pushing 4K at 60 frames per second, that bottleneck is it's a non-starter. So these new solutions, they hit the 18 gigabits per second data rate you need.
And that supports the key formats, right? Like 4.4.4 color.
Flawlessly. Whether it's 4.4.4 at 8-bit or 4.2.2 at 10-bit, the quality is there.
But the real trick is doing that over distance. The sources we looked at say these can go up to 328 feet. That's 100 meters.
A full 100 meters. All while keeping perfect image quality and, crucially, full HDCP compliance.
That is a massive leap.
It is. And it immediately brings up the main question. How do you keep that 18 gigabit pipeline stable over that distance?
Right.
The answer is, it's a hybrid design.
Okay, but wait. If you're talking about fiber, light speed, why even bother with a hybrid? Why not just go all in on fiber? Isn't dragging old school copper along just a compromise?
That's a great question. And it really gets to the cleverness of the engineering here, the heavy lifting, the actual 18 gigs of video data.
Yeah.
That's handled by 4 strands of what's called POF, polyfluorinated optical fiber.
Yeah.
So light is transmitting your video.
Okay, so fiber for the heavy lifting, but the copper is still there for what?
It's there for the handshake. HDMI isn't just a video stream. It needs control signals, communication.
You mean like the ED-DI data so the source and display can talk to each other?
Exactly that. The 6 copper wires handle the DDC, the display data channel, which is what carries that ED info and the security keys. In the current standard, that conversation has to happen over copper.
So it's not a compromise, it's a necessity. You're marrying the speed of light with the existing communication protocol.
Precisely. And this is where it gets really interesting, because the main video signal is now traveling optically.
Which means it's immune to interference.
Right. It has an incredibly low RF profile. You can run this cable next to all sorts of noisy equipment, motors, power supplies, and the signal is clean.
That's huge for what they call mission-critical applications or secure environments.
Absolutely. The hardware doing this uses 4 discrete optical channels powered by these specialized high-efficiency lasers. They're called VCSELs.
Okay, so beyond the tech inside, what about just installing it? These professional jobs often mean pulling cable through some really tight spots.
And that's where the physical design comes in. First, they're plenum rated.
That's the UL CMP AOH compliance for fire codes.
Yes, so you can legally run them through air handling spaces in commercial buildings. That's a huge deal for installers.
And they have to be flexible.
And they are. Incredibly flexible. We're talking a minimum bend radius of just 2 millimeters. A thick copper cable can't do that.
2 millimeters. Wow, so you can snake it around tight corners. And I saw something about removable connectors for pulling it through conduits.
Yeah, that's another really clever feature. You can take off the main HDMI housing, and what's left is this tiny cross-section, just about 12 by 10 millimeters, that you can easily pull through a narrow pipe.
And it does all this without needing a separate power adapter plugged into the wall.
In most cases, yes. The power draw is tiny, less than 1/4 of a watt, and it typically just pulls that right from the source device itself. No extra power bricks to worry about.
Plus, it's TAA compliant, which is important for government contracts.
Right. The whole package is designed for the high-end professional market.
So, if we pull all this together, what we've learned is that these active optical cables are this elegant solution. They use fiber for the high-speed video and copper for the essential control signals.
It's the best of both worlds, really.
So what's the big takeaway here? I mean, for you listening to this, the ability to send an 18 gigabit signal over 100 meters isn't just about a faster cable. It's about a pragmatic hybrid solution.
A technological compromise that targets the exact weakness of the old system.
Yeah, exactly.
And that leaves you with a really interesting thought, doesn't it? This integration of fiber for speed and copper for control. It didn't just solve a video problem. It perfected a technical blueprint.
A blueprint.
Yeah. I mean, consider how this exact hybrid approach could solve other major speed or distance limitations. Think about networking, IoT devices, even localized power transfer, using light for the heavy data and metal for the low-speed control. It's a deep dive for another day.